Hi! I am glad you are still with me on the Bitcoin Tech Tales series. After exploring the Merkle tree and meeting Halvikus, we are now ready to continue our work on building the candidate block. Join me as we dive deeper and continue our exciting journey. By now, our candidate block is filled with verified transactions. The train also brought the total fee container with the total fee tile, and the transaction and witness data hash containers from the transaction verification house. We need the Merkle tree root of the witness data for the next step. So, we fill the Merkle tree with the hashes of the witness data, and as a result, we get the Merkle tree root of the witness data. We also need the value of the current reward height and collect the reward tile from Halvikus's adjutant on our way back to the house. A miner receives a reward for creating a new Bitcoin block. To do this, he sets up a payment transaction called Coinbase. Coinbase differs slightly from the typical transaction because it does not involve spending funds. However, to identify this transaction as a Coinbase transaction, a special coupon with predefined values is placed there. The miner creates a new certificate with the value of the total transaction fees collected and the value of the Bitcoin reward. The miner enters his address as the recipient's address. For each transaction made, a fee was paid with existing Bitcoins. However, the Bitcoins used to reward the miners did not exist. Creating new Bitcoins only occurs due to rewarding the miners for each new block they make. The certificate for the miner's payment is placed in position 0. By placing the Merkle tree root of witness data in position 1, Bitcoin ensures the integrity of all witness data within the block. Since no funds are spent in Coinbase, there is no witness data. The Bitcoin protocol allows using places in the Coinbase for other purposes. For example, the miner provides the candidate's block height number and can insert arbitrary data, such as the miner's name, into the input part of the transaction. The miner has now completed the Coinbase transaction, and before storing it according to the rule on the first position in the block, our hasher, a hashing algorithm, creates the hash or ID of the transaction data box. The miner makes a copy of it and sends it to the Merkle tree. After inserting the Coinbase into the transaction part of the block, the transaction counter and block data size are also stored before closing. The Coinbase hash is the last hash needed to calculate the fingerprint of all transactions in the block, the transaction Merkle tree root. Let us now focus on the block header. Each block header has space for 6 data tiles. These tiles are the block version, the current time, and the transaction Merkle tree root. Today, miners use the block version tile to signal network upgrade support. One tile is already there, it is the nonce number, which is 0 by default. We will explain the importance of nonce later. Finally, to fill in the last 2 tiles in the block header and find the correct number for the nonce, the block leaves this house and moves to the blockchain entrance. Here, at the blockchain entry, we see blocks connected to the previous one. They form a chain of blocks, also called the blockchain. In the next step, the node prepares to connect the candidate block to the last block on the blockchain. Hasher, the hashing algorithm, calculates the fingerprint of the header's data from the previous block, and the node includes it in the header of the candidate block. This is how the blocks are connected to the blockchain. There is still an empty place under the nonce tile in our block header. It is the place for the difficulty target tile. We will explain it and its influence on nonce in the next episode. We've concluded this episode, where we discovered that new Bitcoins are only issued through Coinbase transactions as compensation for miners who create a new block. Once the block is completed with the Coinbase transaction, the miner adds block-specific data to the block header and prepares it for the connection to the blockchain. In our next episode of the Bitcoin Tech Tales series, we'll concentrate on the difficulty target, the final component missing from the block header, and present difficulties, the difficulty adjustment algorithm. Thanks for joining me today. See you.